Hey guys, Girish here. You should really be watching this video after that you've gone through the math exploration workbook, such that you've already have your title now and you've started to develop your ideas, and now you're trying to understand how should the final math exploration look like. All right. So the first thing you should be doing is go through the workbook, get your title, make sure you have the right methodology for the math exploration, get that checked by the teacher. And then once all these things have been sorted out, second step would be to actually look at the assessment criteria. So you've got five of them: A, B, C, D, E. There's another um, workbook on, not workbook, but document on the different assessment criteria and what each one actually assesses. So you should be going through that second document also. And then once you've gone through the two documents and now you're actually ready to write your exploration and you're trying to look at samples and what a good exploration looks like, that's when you should be watching this video, not before. Otherwise, we're not following all the steps. All right. So what I'm doing in this video is I'm actually taking one of the samples from the IBO website, one of the student work, and I'm actually going to use the assessment criteria to evaluate the work so that you can also understand what does the examiner actually what the examiner does when the examiner looks at the work you're going to submit to IBO, and how the person is going to actually use the assessment criteria to evaluate the work. All right. So I'm just going to go through the exploration and try to mark it with you. And there is some level of subjectivity when you actually mark it. And you'll see the way I perceive the assessment criteria, the way I look at it, and the way another examiner looks at it might be different. And I'm going to explain why it could be different. But it's actually good to understand the thought process so that you know exactly what the expectation is. All right. So I'm going to run through it now, run through that math exploration with the criteria, and then explain to you what the exploration is really worth in terms of the different assessment criteria being used on that exploration. So let's look at it together. I'm just going to browse through it, and then you can follow along. So the first assessment criteria is communication, assessment criteria A. And in communication, if you look at the rubric, if you look at the document I've created on the different assessment criteria, you'll see that for assessment criteria A, it's communication, and it's clearly written that you need to have an introduction in your exploration. The aim of the exploration should be explained, and it should have a conclusion. And then the flow of the exploration should be a coherent one, and you should have tables and diagrams at the right places. It's not that you have all the diagrams in one place. The different diagrams and tables should really accompany the work throughout the essay. So when I look at this one, it starts nicely with codes. But then what's missing is actually the introduction. You see that you have two codes here, and then you're explaining where codes were used in the past. So it's saying here it was used by the military to keep secrets and all that. If I had to write that essay, I would have references to the war in the past, and you should you should definitely have an introduction and have a rationale to the exploration, which is missing here. So I can already tell that this exploration won't get a 4 because the introduction is missing. All right. However, there is a flow to it. So it explains the different coding systems and gives examples. And if I browse through it, it seems to be well organized. Okay, you have graphs with the labeling. So it is organized in an okay way as we run through the exploration, as we go down. Let me check if there is a conclusion. You see, so there is no conclusion as well. in this exploration. So there are already three things missing: no intro, no conclusion, no rationale. Okay, so if I'm very harsh at marking, I would give that exploration 1 out of 4. However, there are some good things in the way it's written and the way it's trying to communicate the essence of the exploration to the reader. So that exploration would be eventually, a 2 out of 4. So when I'm looking at it, it's either a 1 or a 2. But when you try to balance things out, it's actually a 2 out of 4. Out of four, and if you go on the IBO website, it was actually awarded a 2 out of 4, and I actually explained to you why it was awarded 2 out of 4. So that's criteria A. Okay, criteria B is the math presentation. Now, in math presentation, they look at the accuracy of your notations, your formula, the graphs you've used, whether labeled, any diagram you've used, all these diagrams created the way they should be created. So let's look at the math notation. So here we have a table. Here it's explaining a sort of mapping. X is mapped onto X plus 2. So it uses an arrow, which is good. That's what we use in functions as well. So no problem here. Division sign use. Let's go down. Factorial. Okay, factorial is written well. That's fine. 4C2, I would have put the 4C2 in a bracket. Okay, but it's not a mistake. We can't penalize the student. However, I'm a bit annoyed with this one. The factorial in front of the 4. I don't think that's proper notation. So I would deduct a mark for that. All right. Graph seems fine with the labeling. Okay, NCR use, factorial use. You see, I'm annoyed with this one as well. So between the factorial and the multiplication sign, there's no space. Okay, so I would penalize a student for that when it comes to math presentation, because for me, it's not proper math presentation. Otherwise, power written well, brackets used well, proper use of brackets here, that's okay. You see the numbers and the line in the table, that should be centered. So to me, I wouldn't award full marks. These are minor things, but it's not proper presentation. Okay, so, all right, so I would deduct at least 1 mark. We can't award 1 out of 3 for the math presentation because that's a bit too harsh, because there's no major mathematical mistake in the exploration, but I would give it 2 out of 3. However, if you go on the IBU website, they actually awarded 3 out of 3. So math presentation was perfect. But that's the part where I don't agree with the one who marked it. I think it should be a 2 out of 3. So if I was marking as an examiner, and I am an examiner actually, I would mark 2 out of 3 instead of 3 out of 3. I don't think it deserves a 3 out of 3, but it was given a 3 out of 3 by IBO. So that's where I say we don't always agree. So that would be for math presentation. Then you've got personal engagement. So the personal engagement is how engaged the student has been throughout the process when the math exploration was done. So usually the teacher is a good person to actually judge how involved and how committed the student was. But if I look at the exploration, there's actually the student is quite engaged because there are lots of things explored. And I think on page, so if it is an SL student, we're talking about here, the student is exploring the Maclaurin series, which is not in the syllabus. So that shows commitment. And I think on page 9, the student creates her own table as well. So let me show you where it is. So here, this table on page 9. So this table was created by the student. The student, tries to replace the value of n and checks whether these values are factors and then has to actually go down up to 438, 439, and 440 to actually find a factor. So it shows commitment, perseverance, and if that work is produced by an SL student, it's a lot of commitment. So we won't award the lowest score. So for personal engagement, it's out of four. You would give that student a 3 out of 4 at least, and that's what IBO gave to that student. It was a 3 out of 4. Then the next criteria is reflection. So that's criteria D. So reflection most of the time is found in the conclusion, which we don't have one here. So that's already, again going against that student because we don't have a conclusion. If when I scroll down, you see that it just ends abruptly and then it gives you the bibliography. So that's something you should really avoid because these are like very simple things which should be present in the structure. It should have an intro, it should have a rationale, it should end with a conclusion. So the student doesn't produce a conclusion. So already it's out of 3 marks. You know, you already lose at least 1 mark. However, reflection can happen throughout the exploration. But if you read it, there is math in it, but the student does not. I mean, the student goes through the different experiments and codes the things and all that, but it doesn't show very insightful reflections throughout the exploration when you read it. They are just things which were worked out, and then the student explained what was happening. But there is nothing which strikes you as, oh yeah, you actually hit on something which is very valuable. Okay, so that's probably going to be the lowest rating for the student. So the student gets a 1 out of 3 in terms of reflection because the math is done well. Okay, we can't argue against that, but there's no major insight, and these insights which I'm talking about, whereby you really write in a condensed manner what you found in the exploration and what were the highs, so what really worked and what didn't work, and advice for future people reading the exploration, what can they explore further. That's where you get the marks for the reflection, and none of these things are present in the exploration. So the student gets 1 out of 3 for the exploration. And then last criteria is use of math. So as I was saying, if it's work coming from an SL student, the math is quite substantial. The student uses NCR, uses the Maclaurin series. The student comes up with her own table on page 9, goes through different coding systems and explains. So the math is enough. So factorial, it's it's well worked out, and there are no mistakes in the workings. Actually, if you are a teacher, you need to go through each line of the working and check whether there's any mistake. But in this one, there is no mistake. The math is done well. The simplification happens neatly, and yeah. So in terms of math, everything is executed perfectly, and it's clean. And the level of math is outside the SL syllabus. So if it's someone from an SL group, you actually need to award full marks to that student, and this is what happens um, in this in this case. The student gets full marks, 6 out of 6 for the use of math. Um, but that's where we need to actually explain what would happen to an actual student. So if this work is produced as work coming from an actual student, then the student won't be getting full marks because you would expect more from an actual student. So for an actual student, uh, the standard feedback we usually give as teachers is that the work was good enough. It was commensurate with the syllabus, meaning It is of an appropriate level, but you won't get 6 out of 6, but you will get 4 out of 6 because you would expect more from an actual student. So if you're an SL student, it's good enough. If you're a natural student, then we actually expect more. So we'll need something more advanced, something more abstract, which would lead to actually more sophisticated thinking, analysis, and reflection. So that's what you would expect from a natural student. But it would still be a decent exploration, even if it was produced from an actual student. So yeah, so that's this example explained to you.